Within a single metallic sphere lies the technical blueprint for the end of the world.
A nuclear detonation releases its energy in a fraction of a second, but the darkness it casts over the planet can last for decades. In this report, we are tracking the specific sequence of events triggered by a modern nuclear explosion, following the physics from the subatomic level inside the warhead to the collapse of the global climate. A nuclear exchange causes 4 systems to fail in a rapid chain reaction: the immediate kinetic blast zone, the radiological biology of the survivors, the upper atmosphere, and the global agricultural supply chain. Current research focuses on the threat of a regional nuclear exchange between smaller powers. This scale is sufficient to trigger the global sequence we are analyzing today. The danger of a modern weapon extends beyond its explosive yield. A detonation interacts with the atmosphere to alter the environmental systems that maintain our food supply. Modern thermonuclear weapons use the Teller-Ulam configuration. This is a staged design that begins with a fission primary. This primary is essentially a standard atomic bomb, where conventional explosives compress a sphere of radioactive material, forcing atoms to split and release a burst of energy. This primary explosion creates intense thermal X-rays. In a process called radiation implosion, these X-rays flood the casing and compress a separate fusion secondary. Radiation implosion uses the pressure of these X-rays to crush the secondary fuel capsule with far more force than chemical explosives could provide. This secondary capsule contains lithium deuteride, a solid compound of lithium and a heavy isotope of hydrogen. When compressed, these atoms fuse, creating temperatures that exceed the center of our sun. This heat vaporizes the surrounding material, forming an expanding nuclear fireball that incinerates everything in its immediate radius. The expansion of the fireball displaces the atmosphere, creating a kinetic shockwave. This wall of high-pressure air travels outward in a sphere, flattening reinforced concrete and leveling cities for miles. The physics of staged radiation implosion convert a small mass into an unstoppable wave of pressure and heat that can erase a metropolis. As the blast gouges a crater, it scoops up thousands of tons of pulverized rock. Radioactive isotopes attach to this debris and fall back downwind as local fallout. For populations in the fallout path, the hazard is acute radiation syndrome. This is a severe illness caused by a high dose of ionizing radiation that penetrates the body and destroys rapidly dividing cells. Survivors further away face low-dose ionizing radiation, or LDIR. LDIR refers to radiation exposure that is above natural background levels, but too low to cause immediate tissue damage. Instead, it damages cellular DNA, increasing the risk of cancer and cardiovascular diseases over a lifetime. Studies on the F1 generation, the children of atomic bomb survivors, found that heritable mutation rates were statistically much lower than scientists originally anticipated. While radioactivity decays exponentially over the first few weeks, weather patterns can wash isotopes into concentrated areas, creating lethal hotspots that remain in the soil for years. While the kinetic blast destroys the architecture of a city, the resulting fallout poisons the biological future of its survivors, creating a multi-generational health crisis. The destruction continues long after the blast. The initial thermal flash is hot enough to ignite citywide urban firestorms across the target zone. These intense fires consume modern infrastructure and create self-lofting convection currents. This process pumps millions of tons of black carbon soot particles that are highly efficient at absorbing solar energy into the stratosphere. This temperature graph shows the result. Because the black carbon is injected so high, it spreads globally and blocks direct sunlight, causing a steep plunge in surface temperatures that can last for a decade. This bar chart shows the impact on global agriculture. Without adequate sunlight and warmth, foundations of the food supply, like corn, wheat, and rice, face an estimated 80% collapse in yield. The breakdown of trade buffers and failing marine ecosystems lead to a level of famine that overwhelms existing humanitarian mechanisms. A localized detonation triggers an atmospheric chain reaction, transforming a regional border conflict into a global famine. The timeline is brutal. It begins with a microsecond of X-ray compression, erupts into a regional firestorm, and ends with a global freeze. During the atomic age, the pace of scientific invention was staggering, yet there remains a lack of preparedness for the long-term ecological consequences of these devices. Modern arsenals are integrated into a global system where any regional conflict carries inescapable consequences for every nation on Earth. We have to understand the interconnected nature of our climate and food systems now and build resilience before a crisis occurs. We mastered the physics of our own destruction in less than 3 years, but the science of surviving it remains.
The detonation is just a fleeting prologue to a planetary silence that will outlast our history.